Chemistry 12.6. So there wasn't a whole lot of great details in here. Um, but the two new words are surface tension and then viscosity. So I'll explain those in a sec. Uh, Next time up, 12.7 is going to be an almost identical reread to 12.1. 12.1, you read about a lot of stuff about gases, or about liquids, which was pretty much a reread from chapter 11 when you read about gases. So we had all this stuff about gases, about fitting any container, expands to fill any space, all that stuff from chapter 11. Liquids, they made some adjustments to those thoughts. Solids, 12.7, they'll make some adjustments to those thoughts. And you'll have 5 new points. There's more than that in it, but it'll be like the first day questions always are. Tell me some of this, tell me some of that. You know, if there's a list of 5, I probably only want you to name like 2, something like that, or 3 out of 6, or 1 out of 3, or whatever the case may be. So when you read, you'll see a fair amount of points, but there's only going to be 5 make the quiz because you'll only name some of the stuff, just like you did on 12.1. If you look back at the 12.1 quiz, it's pretty similarly laid out to the way the 12.1 quiz was laid out. In terms of reworking, the new words, I'll sort of explain them while I rework them, I guess. Surface tension, next time you see it, I'll just say, instead of number 1, fill in, I'll say, what is surface tension? And you can go from property toward the end. It'll be the property of a liquid that tends to draw the surface molecules into the body of the liquid and minimize the surface. I'll ask you what causes it, and you'd say attractive forces everywhere but up. Attractive forces everywhere but up. So here is a little picture for you. So the idea is, if you have a container full of, say, water, water's the easiest liquid usually to imagine. If you have a molecule that's here in the middle, it's getting pulled right because there's water to its right. It's also getting pulled left because there's water to its left. And those two should basically balance out. There would be a pull down because there's water under it. There'd be a pull up because there's water above it. And a molecule in the middle of the body of the water, really, the net is 0. Every force is balanced by a force pulling it in another direction. You could say that it's in equilibrium, to use a word we've had another day. But if you go to the top, the very surface, and you pick a molecule up there, there's still some water pulling it right and left evenly, but there's a downward pull toward the other water, but there's not water above it to balance that out. So if you're at the surface, all of the attraction at the surface, any molecule at the surface is getting pulled down. And so that makes the top just be a little bit more dense, a little bit more thick. Okay, so that's why sometimes if you throw something like a leaf into a body of water, it'll just sort of float there on the top for a little bit, okay? But it's not going to float there forever. Sooner or later, it's going to pierce or puncture that top thicker level, and it's going to sink. Some of you swimming pool owners know that. You have a swimming pool, the leaves from the tree fall on the top of the water, they're there, they'll float on the top for a while, but they're not going to stay there forever. Okay, your leaves from fall are not, come spring, still floating on the top. Eventually, every one of those leaves is going to pierce that top and sink. You see bugs sometimes walking on the top of the water because of this surface tension. It can materialize in other ways as well. I suppose the same thing could be happening kind of like on the bottom and on the sides even too, because you have that same imbalance. But there's a different thing going on there that I'm not going to belabor the point on this. But on the sides, the question becomes whether the water is more attracted to the item or to itself. So sometimes you might have some water that it gets to the edge and it's more attracted to the water, and there's sort of like a bend down at the corner. Sometimes you might have something that's more attracted to the container than to the other water, and then it might sort of have a bend up at the corner. Something like when you wax your car. Okay? Water doesn't like wax. So if you have a surface of your car and there's water, the water is more attracted to the other water than to the wax, and it'll sort of beat up. and roll essentially off your car. Mercury does that. Mercury is a liquid that forms beads and balls and rolls around. But if your car is not waxed, water doesn't so much mind metal, okay? So if you have water on your car and you haven't washed your car for a while, you're gonna get like a thin layer of water that all like spreads out. Okay? But that's off point from what we're talking about today. We're just talking about surface tension makes the top of this a little bit thicker. But around the edges, different kind of things can happen, but similar. It's just a question of whether the liquid's more attracted to itself or to the container that it's in. Some of you that have dishwashers at home full well realize when you wash plastic stuff, the water sticks on there. It's pretty attracted to it. But it's not so attracted to glass. Like you open your dishwasher, your glasses are probably dry, but your plastic cups are not. That has to do more with a concept for another day. But surface tension is the water's just getting a little thicker on the top level. I have a note on here that doesn't make the quiz, but it's worth a mention that they talked about this in the reading. Alcohol and soap both are two different kind of items that can lower surface tension. That's why if you cut your hand, you want to use soap or alcohol to clean it out, because it lowers the surface tension and it can penetrate into those cuts, into those gaps, into those things. But that's not making the quiz, but soap and alcohol both can lower surface tension. Another way you can lower surface tension is to raise the temperature. The warmer something gets, the easier it is to puncture that top layer, because there's more energy. The particles start moving around more. They tend to want to spread out more because they're moving around more. It's just a little easier to puncture that top layer if temperature is higher, and that does make the quiz. So it'll be, for one, what is surface tension? Just go from what I typed, property, to the end. It'll ask what causes it, and that was having attractive forces everywhere but up. Since the attractive forces were down on balance, that's what happened there. And then what you can do to decrease surface tension is raise the temperature. Viscosity, we'll go backward. Viscosity, I'll just say what is viscosity, and you could go just from the word resistance to the end. It's the resistance of a liquid to flow. Some liquids are not very viscous. It does not resist flowing. Honey is viscous. Good luck pouring honey and having it like go anywhere. It's just not going to be cooperative. Honey has a high viscosity. Water would have a low viscosity. You know, if I had like an incline like this and I poured water at the top, it'll run to the bottom pretty fast because it doesn't resist its flow. If you poured honey at the top and waited for it to roll downhill, it'd be a while because it's viscous. So viscosity is a resistance of a liquid to flow. So low viscosity means it'll flow just fine. High viscosity means it kind of gums up on you. Follow-up question on this. What you can do to increase viscosity is put the temperature down. That's why your cars are not real thrilled about the morning sometimes, because the oil and the other fluids, when it gets colder, the fluids in your car are more viscous. They don't want to flow. They don't do well. School buses in particular sometimes have issues just getting warmed up in the morning and overcoming that viscosity that gets you your 2-hour delays. So viscosity is probably your friend. Alcohol and water, I have a note on here, it doesn't make the quiz, but alcohol and water are two things that they do flow easily, so those are low viscosity. Alcohol even lower than water. But that is our 12.6 theories. I'll see you for 12.7.